So, good morning, everyone. My name is Thomas Thyen. I'm a Cloud VMware Solution Specialist, and today I'm joined by Vaibhav Tiwari, my colleague, and together we are exploring the different storage options and capabilities of the Oracle Cloud VMware solution. Starting with that, a quick look at our safe harbor statement, and then we are directly going into a general overview about the Oracle Cloud VMware solution. So generally, to give you an overview what it is and how it works in basic details. So Oracle Cloud VMware solution is a software-defined data center solution that we jointly developed with VMware. So the service itself is fully VMware certified and verified. And it's made up of the two pillars that we see. The one pillar on the left is the VMware software and support stack that we have for the ESXi, vCenter server, vSAN, NSXT, HCX, and so on. And basically, we are offering this in the version 7, vSphere 7. And for existing customers, we are still have the offering with vSphere 6.5 and vSphere 6.7, but only if these customers already have provisioned software-defined data solutions with the older versions. For new customers, they are not available anymore because 6.5 and 6.7 are out of general support since October 2022. And yeah, the other pillar will be the Oracle Cloud infrastructure. So we as Oracle, we are providing the bare metal servers and the whole cloud infrastructure. So compute, networking, everything that you need in the cloud to run your VMware solution. And this then, in the end, combined what we see in the middle here, really brings then together our cloud VMware solution. So the Oracle hardware and cloud stack together with the VMware software stack will provide you your software-defined data center. Basically, we have two different offerings from the bare metal shapes that we provide. It's either Intel shapes or AMD shapes. And as you can see from the cores and memory, there are huge differences. And from the storage level, they are almost up to the same. But we will get more into the details later within this session on what are the differences between the Intel hosts and the AMD hosts. In generally, our software-defined data centers scale from a C node SDDC to a 64 node software-defined data center. So you need at least a 3 node deployment when you want to run production workloads or your disaster recovery workloads and so on. If you just want to do a quick test, a proof of concept, or run some really test workloads on our Cloud VMware solution, we also offer the single node SDDC. But as just said, it is really not designed for production workloads, as we can not guarantee any high availability virtual machines and for the data on a single node SDDC. Yeah, with that said, I would like to focus a bit on the key differentiators from our Oracle Cloud VMware solution compared to other cloud or VMware cloud providers on the market. Basically, from a security standpoint, our environment is fully isolated, has a zero trust security concept, and is running within the customer's vCN. So basically, we as Oracle do not have any access to your Oracle Cloud VMware solution environment. So you as a customer or as a managed service provider are fully responsible for the security within your Oracle Cloud VMware solution and can really design the security of your OCVS environment like the security design that you have on premise. So this also brings then the operational efficiency that we are bringing with OCVS, as you can do your operations of OCVS the same way like you do it with your on-premise environment. You can use the same tooling, you can use the same scripts, you just have to adjust it and run it on OCVS. This is something you probably cannot do with other cloud providers because they offer managed service for the VMware environments and you do not have the full control over it. This is fully different with OCVS. You have the full root access. You can do any configuration on this environment that you want to do. There's no restrictions from Oracle. So this is your full root access VMware environment. And of course, our Oracle Cloud VMware solution, or at least the virtual machines that are running on top of the Oracle Cloud VMware, can fully integrate with all our cloud services, like the database services that we offer, the block storage offerings, the object storage, and Oracle Integration Cloud, for example. So basically, every Oracle Cloud service that is available in that region is also be integrated or can be integrated with Oracle Cloud VMware solution. I was talking earlier before about the deployment models that we have with the different shapes. So we can differentiate between Intel shapes and AMD shapes. And with the Intel shapes and AMD shapes, there come different CPU core ratios that we have in the end. We will get more into detail on the shapes later in the presentation. But with the AMD, we have the offering that you can use different types of hardware-enabled or hardware-disabled CPUs that we offer, that you can more granularly size your AMD clusters instead of Intel clusters, for example. Unique deployment models really means we have a standard deployment, which is within a single availability domain, but we're also offering a fully unique deployment model for Oracle Cloud VMware solution, which is only available on Oracle Cloud. No other cloud provider has this, which is our Multi AD deployment. We will come to that later and to give you a bit more insights on that, but this is a really unique selling point of OCVS, because with that model, you get the highest availability for solutions in the cloud. And last but not least, which is or what this session is all about, our storage solutions. So we have multiple storage options, and yeah, with that, let's have a quick look in the storage options that we have. It's 3 in total. So the first storage solution that we offer, and this is the, let's say, primary storage solution that comes with every Oracle Cloud VMware solution deployment, is the VMware vSAN data store. The secondary solution would be to integrate your OCVS solution with Oracle Cloud block volumes. So these are iSCSI based, and third options that we have is an NFS volume that you can map to your Oracle Cloud VMware solution, and this is based on Oracle Cloud file storage service. So basically what you can see here, the solutions that we offer, the vSAN data store, so hyperconverged storage, block volumes, block storage, or NFS storage, are basically almost the same storage solutions that you get offered in your on-premise environments as well, which brings you again the capability to replicate, for example, architectures on VMware that you're running on premise fully in the cloud with Oracle Cloud VMware solution. So to give you a general overview about VMware vSAN, because this is the first storage solution that we offer, I would like to introduce you a bit to, on a very high level, what the technology behind it is. In the end, as I already mentioned, we are starting with a 3-node deployment, as we can see here with our bare metal hosts, and every bare metal host has local storage. So we have local NVMe SSD storage in these hosts, and basically what the VMware vSAN data store is doing, it is aggregating the local storage of all the hosts and building a vSAN data store, which is, in the end, it is a virtual data store that is aggregating the local storage. So this means you can place your virtual machines on top of it. You can do replication of data from on-premise to your vSAN data store, and you can host virtual machine templates on it. Everything that you're going to do on your on-premise environment as well. And as already mentioned, it can scale from a 3-host cluster, which is the minimum, to a 64-node cluster, which is the maximum. So this is also a VMware limitation, because vSAN can only scale to 64 nodes. And but in the end, we recommend building smaller clusters to separate your workloads, because in the end, it's more suitable to have smaller clusters in terms of performance. From the minimum sizings that I was talking about earlier, I would like to give a bit more detailed introduction to that. So we have the Intel nodes and we have AMD-based nodes. And basically what we can see from the storage perspective, as already mentioned, so this is an example for 3-node cluster. They're almost at the same level, so it's 130 terabyte to 122 terabyte. In the end, in larger scale clusters or in the most environments, the storage difference between Intel and AMD does not really matter really in the end, because we are talking about, 7 terabyte in total. So it's not really something that is driving your overall storage consumption. From the CPUs, we see a totally different model. In an Intel cluster, you can go up to, we have at least 156 OCPUs and 2 terabyte of memory around about that you can use. When we look at the AMD clusters, you at least get 3 times the memory that you get with an Intel cluster. And of course, also when we go to the E464 or E428 shapes, you will get a lot of more CPU capacity with these types of AMD clusters, which means in the end that you can host a lot of more virtual machines on the AMD E64 and 128 clusters than you can run on an Intel cluster, for example. So this means higher density means that you have lower cost per virtual machine on this environment, because you're hosting a lot of more virtual machines on this host. And it brings also the advantages that, for example, when you need to scale out, you need more CPU and memory resources on an Intel cluster compared to an AMD cluster. You also have to consider guest operating system licensing, because when adding a new host to an vSAN cluster or to an OCVS cluster, you also need to do the licensing for the underlying hardware. So for Microsoft Windows operating systems or for enterprise Linux operating systems, Oracle Linux, Red Hat Linux, SUSE Linux, for example, and some other enterprise Linux operating systems. So there's always additional cost involved. And this is where our different storage options, what we will see in the next slides, will make a big difference in terms of scaling and really optimizing capacity and optimizing cost for your VMware environments. So basically, as already said, we have these different deployment models and standard single AD deployment, how we call it. It's basically an OCVS cluster or a Cloud VMware Solution cluster that is spread across 3 fault domains. So fault domain is a rack unit on rack within one of our data centers. So basically, this VMware cluster is then distributed by the bare metal host across 3 fault domains within the availability domain, which then brings us to the level that we can guarantee high availability for the services and for the whole VMware service within our data center, as we are not putting all the hardware within one rack. If a rack should fail, the whole solution would fail. So this is why we are spreading it across 3 fault domains and spreading it across multiple racks to give you the availability that you need for your virtual machines and for your data. This is not a very special deployment, because this is a deployment that you get with every other cloud provider as well. But now we are coming to the unique point of our Cloud VMware solution. And this is our Multi AD deployment, where we are then distributing our bare metal hosts across 3 fault domains. This solution is only working in the region where we have 3 data centers, for example, Frankfurt or Ashburn, Phoenix, and so on. And basically what we are doing here is we are distributing our OCVS bare metal hosts across the 3 fault domains, and then we are actually distributing a cluster, a vSAN cluster, across all this availability domains. So we have a regional VMware cluster, and this cluster in the end brings the highest availability for your virtual machines and data that you can have with a VMware solution in the cloud. So this is fully unique on OCI. You cannot get this deployment with any other cloud provider. And this really comes into play when you have customers that require really high SLAs for their workloads running on top of OCVS that you probably just can only afford with vSAN stretch clusters and so on, which are very complicated constructs in the end. So this is an easy and cost-effective solution to bring the highest availability in the market possibility for virtual machines on a cloud solution. And yeah, basically this is what our vSAN solution looks like. And I would like to give you an introduction now onto a little use case that we prepared to show what are the capabilities of Oracle Cloud VMware solution and how it works in terms of scaling and if you need to scale. For that, we have this use case where we are starting with a 3-node cluster. And the challenge here is that we should extend the storage to meet the storage requirements at the lowest possible cost. So what we see in the end is we have CPU resources, we have memory resources, and the CPU requirements and memory requirements are below our CPU and memory resources. So this is fine. So we are meeting CPU and memory requirements. But as you can see, for the storage requirement, what vSAN is offering is much less than what this customer needs in terms of storage, because he has a very high storage demanding application running on top of Oracle Cloud VMware solution. So, so what do we have to do in the end? We have to increase the storage capabilities or capacities that we have on Oracle Cloud VMware solution. So the obvious case that we can do, or the option that we have, is really, okay, let's add another bare metal host. That's pretty easy in the end. You can do that within minutes via the Oracle Cloud Console and integrate it into your environment. And yeah, what we can see is now we meet the storage requirement. We still have a few vSAN resources left, which is fine because you're never utilizing a vSAN cluster by 100%. So this is fine. But as you always can, but what you also can see is that we are also having much more CPU and memory resources now that we are not utilizing because we're forced to increase the storage. So the problem here is, in the end, because vSAN is scaling linearly in the end. So if you add a bare metal host to add more storage to it, you're automatically adding CPU and memory resources that you probably do not need. So the problem here is you have to pay for the CPU and memory resources, but you're not utilizing it. So this is pretty costly storage what you're adding to your solution. And of course, like already mentioned, the other trade-off is you also need additional guest OS licensing here. So you always have to account for new more licensing for Windows servers and for Linux enterprise servers, for example. So what could be another option to overcome this challenge? And this is basically, we are going back to a 3-node cluster and we're adding an OCI block volume. So in the end, we are still meeting our CPU memory resources because they were sufficient in the 3-node cluster as well. So we do not have really wastage here. And actually, to meet our storage requirement, we are filling the gap with an OCI block volume, probably 32 terabyte or something like that we need here. So the advantage here is we are also, in the end, we are just paying for the cost of an OCI block volume. We have no waste of CPU memory resources because we still need some spare resources in the backend. We have no additional cost for the guest OS licensing because the guest OS licensing from the beginning was calculated for the 3 nodes and they are fully licensed, for example. And we have no cost for an additional bare metal host. So in the end, we are just ending up with the cost for the additional block volume. And this can scale from 1 terabyte to 32 terabyte for a single block volume. And at least, yeah, you can connect up to 32 block volumes to your Oracle Cloud VMware solution environment, which brings really a massive scale of storage that you have and really brings you the advantage to scale your storage independently of your CPU and memory resources, because we see customers in the market that have applications running that have an 2 or 3 times higher storage demand than they have in demand for CPU and memory resources. And this really then shows the advantages of this block volume integration with Oracle Cloud VMware solution. And basically with that said, yeah, I would like to hand over to my colleague, Vaibhav Tiwari, and he will give you a more deep dive overview on the OCI block volume and iSCSI integration with Oracle Cloud VMware solution. With that, over to you, Vaibhav.
Thank you, Thomas. Let me quickly share my PPT. Okay, let's talk about Oracle block volume and how it can integrate with OCVS SDDC host. OCVS SDDC offers vSAN storage as the primary storage, as we saw earlier. And the customers might have requirement wherein they want to expand storage only. For such scenarios, instead of adding ESXi host, we can add block volumes as a secondary storage. It takes less than 5 minutes to add block volume as a secondary data store. And in a moment, we will do the demo for the same. Here is a general overview for the block volume. We can start as low as 50 GB per volume, and it can be scaled, as my colleague said, to a maximum of 32 terabytes per volume. When increasing the size of the volume, it can be incremented on a per GB basis. So we start with 50, we can go with 51, 52, 53, and so on, we can increment. We can have a maximum of 32 block volumes on our OCVS cluster. At a ESXi level, they can be maximum, connected to 8 ESXi. So one block volume can be connected to maximum 8 ESXis. Now, if we have 32 block volumes with the maximum capacity, then as my colleague mentioned, we can have a huge space of 1 petabyte. Now, the best part is that we can create virtual machines directly on the block volume data store. And the ones which are running on the vSAN data store can seamlessly be migrated to block volume storage. Now, a group of files make up a virtual machine. Now, these files, that is the virtual machine, is placed on a data store. Now, with time, we will keep adding virtual machines in our environment, which will keep consuming the available storage space that we have. VMware offers a functionality wherein its internal algorithm can manage the space on the data store, which is backed by OCI block volume, and it can move the virtual machine from one data store to another data store if required. We can add multiple block volumes, then they can be added to a data store cluster. Data store cluster is specific to VMware. And with data store cluster, we get the functionality of storage DRS. What basically it is doing for you is we have options on storage DRS wherein we can specify that how much free space, what is the minimum latency, that a data store which is backed by OCI block volume should have. Once those thresholds are about to be breached, what VMware will do is VMware, by running its internal algorithms, will move the virtual machines to another data store, making sure that the virtual machines are getting the required amount of space and the required amount of IOPS and latency to make sure that the applications are working well. So VMware will automatically move the virtual machine from one data store to another data store, all backed by OCI block volume. And the best part is there is no human intervention required. This can be done on the fly, on its own, and the system, VMware, will automatically take care of it. OCI block volume also provides cross-region replication functionality. Let me elaborate with an example. So let's say that we have a UAE customer wherein their production OCVS SDDC is running in Dubai region. They have provisioned OCI block volumes and the VMs reside on those block volumes which have been made a data store on VMware. The customer has set up a DR and is replicating everything in Abu Dhabi region. Now, with cross-region functionality, we can replicate the block volumes to Abu Dhabi region. If due to any reason, our primary site, which is in Dubai, is not available, then we can connect the replicated block volumes as data store to OCVS-SDDC in Abu Dhabi region. All the data will be replicated and we can register the VMs and power on the machines. We will demo the same again in a couple of moments. To summarize, OCI block volume can be used with OCVS for following use cases. Storage extension, which is adding block volumes as data store where more storage capacity is needed. It will eliminate the need of adding ESXi for storage. For disaster recovery, it can be used to replicate data to another side, and replicated block volumes can be mounted as a data store. We can also keep the backups of the virtual machines on the block volumes for a faster recovery. Now, I'm going to show you a demo on OCI block volume. So I will begin by showing you on how we provision an OCI block volume and attach it to the ESXi as a data store. And then in the next demo, I would show you on how to cross-replicate from one region to another, how that functionality works. So I'm going to stop sharing my screen and let me quickly share the demo that we have created for you. I will share my screen again. Okay, so here I have a one node SDDC that I've created in my lab. Now this one node SDDC comes with a by default data store, which is the vSAN and the primary data store. Now, if I take you to the Oracle portal, the SDDC is deployed in AD1. It is in Frankfurt region in AD1. And now to create a block volume, I basically go to the hamburger menu, go to storage, and then click on block volumes, and I am on the screen. To create a block volume, just click on the button, create volume, specify a name as you feel like. Now it is important to highlight over here that a block volume is a AD specific service. So it is available in an AD. So it is important that we create the block volume in the same AD where our SDDC is deployed. So our SDDC is deployed in AD1, and we will be selecting the same AD over here as well. So we will specify a name over here, make sure that the AD is okay. It comes with a default size of 1 terabyte. We can change it. I'm taking 450 GB for now. The rest, we keep everything as default, and then we hit the button, create block volume. Now, this would take a couple of minutes and the block volume will be provisioned. Block volume is offered by Oracle as a service, so we do not have to worry about maintaining the block volume. It is all done for us. In a couple of minutes, it will automatically change to the available state. And now we need to attach the block volume to the ESXi. So we will click on the button, attach to the instance, and the block volume will be connected to multiple ESXis. So I am choosing over here, read, write, shareable. And I understand that the operating system needs to know about the shared mechanism. I'll choose my ESXi over here on which it needs to be connected. And then I hit the attach button. Now I need to repeat the step for all the other ESXis on which I would like the block volume to be attached. So we can have a maximum of 8 ESXis. So I would have to attach one by one all my ESXis over here on which the block volume should be presented. Now again, it will take a couple of minutes, and very soon we will see that the attaching state will turn into green. Now, once this is turned into green, then we will move on to the VMware portal and start managing it from there. We can also refresh the Oracle portal. Sometimes it might not auto refresh, so we can hit a quick refresh and it'll show us the information. Now, for ESXi to know about the block volume server, I need to copy the IP address of the iSCSI. So here I can get to know about the iSCSI server IP. So I'll copy the IP over here for this specific ESXi. Now I go to the configure tab on the ESXi, and under storage adapter, I see that I have an iSCSI software adapter, which is provided by default. Under dynamic discovery, I will click on the add button and then click on add, enter the IP address that I copied from the Oracle portal for the iSCSI, and then hit the rescan storage. This is basically trying to find out for new storage. So we hit the button rescan storage. It is like a refresh, like an F5 on a Windows machine. So we hit the button rescan storage, hit the OK button. We will see a task at the bottom getting completed in a very quickly. And then when we go to storage devices, and if I do a filter, I would see that I see my 450 GB volume that I provisioned on Oracle, and it is an Oracle backed disk. And now I need to create a data store. So I would make a right click on the ESXi, click on new data store, choose the type as VFMS for the file system, choose my volume, again 450 GB in size that I provisioned, and give it a name. And then hit next, choose the file system VMFS6, which is the latest one, go with the defaults using the complete space and hit finish. Now it will take a minute or less than that. The volume will get provisioned. If we refresh, we would see our option over there. Now, so here we have now looked at that how my block volume can be provisioned and attached to the ESXi. Let's talk about on how to replicate it. So the next demo is about on how when we have an existing volume, on how it can be replicated to another location. So let me again share my screen and now talk about a cross-region functionality. So what I've done is that my SDDC is in AD1, where I have a block volume now. It is also in AD1. It is already connected to the ESXi, and I have also formatted it and created a data store like we saw in the last video. It is connected to my ESXi in test SDDC1. And if I go to my ESXi on VMware portal, I would see over here that I have my block volume connected over here of the 450 GB. Now, if I talk about my volume, it shows me the space that I have. It is the same space, so via which on the Oracle portal that I created, the same space that I see over there. Now, what I've done is that I have created two virtual machines and I have placed them on this data store. Both the virtual machines are consuming close to about 100 GB of data on the storage, and now this needs to be replicated. So what I've done in my lab is basically I have two SDDCs. So they both are in Frankfurt region. So my first SDDC is in AD1 where we connected, and my second SDDC is in AD3. So for block storage, anything outside the availability domain is basically a cross region. It can be to another availability domain, or it can be another region. Block volume will consider it as a cross region replication. So here is my second SDDC that I'm highlighting over here, that it is in AD3. And now what I need to do is for my existing block volume, I need to create a replica. Okay. And the replica that I would create over here, by default, block volume would not have that functionality enabled. So I need to enable that functionality. So when I hit my edit on the block volume and scroll down, I would see a cross-region replication. Here it would show me all the regions which are allowed to have the replication going. The replication is restricted in the sense from where we can replicate to where when it comes to block volumes. So here I am replicating from AD1 to AD3. I can also do it in other regions which are allowed from Frankfurt to be replicated. So I would be choosing it for my AD3 because that is where my other SDDC resides. I'll give it a name for easier understanding. Now, when we hit save changes, we would see that our replica has now been created and it is in the process of getting created. So this is where I would see my replica. Now, to see the provisioning state of the replica, where it is, what we need to do is that we need to go to storage. So I'll navigate back to block volumes. And here under replicas, you would see that it is getting provisioned. So the block volume that I have of 100 GB, I am creating a replica for it. Now it will take a few minutes. That is why I paused the video over there to save on time. And we now have the replica in the green available state. Now what we need to do is we need to carve out a new block volume because this is in another AD and this is a replica. So we need to now carve out another volume. And for that, what we do is we click on the button activate. So when we click on the button activate, a new portal will come up. It will say that, are you sure you want to activate? And I would say, yes, I want to activate. And now here it will tell me that it is basically carving out a new block volume. So what would be the name? In which compartment would you like to keep it? If you would like to change the size of the block volume, or if you would like to replicate this volume again. So I choose the default options over here and I hit the button go. So basically now it is activating the volume. So now if I go back to my block volumes and if I hit a refresh over here, I would see that my new block volume has been carved out. Okay, this is the name that I had, and this is in availability domain 3 now, which is where my other SDDC resides. Now what I need to do is that I need to attach it to the ESXi's of my other SDDC. So I'll again do the same thing, attach instances, choose a read-write shareable, understand the warning, and then I choose my ESXi where it needs to be attached to, and then I hit the attach button. Now again, this will take a couple of minutes, and very soon it will attach this block volume to this ESXi. Again, we need to make sure that all the ESXi's on which we would like this volume to be connected, we need to attach all of them one by one. So right now I've only attached my first ESXi. If you would like to attach it to other ESXi's, we need to add them one by one. Now, if we do a refresh, in a couple of minutes, we would see that this is now created. Again, we now need to copy the iSCSI information because my new ESXi, which is in my other SDDC, would not understand that where the block volume is or how I should reach that block volume. So I would be copying the IP address so that it understands where to look that server, where to look that block volume for. So I copy the IP address over here and go back to my ESXi. And again, over here under configure, storage adapters, my iSCSI software adapter, I go to dynamic discovery, and then I copy and paste in the IP, go for the rescan storage, which is basically a refresh. And now this task will quickly get completed. And now when I go to storage devices, I would see my 450 GB volume presented now. This is the replica volume that we activated and carved out a block volume. So this is the volume now presented on the ESXi. So I would copy the name and I would now create a new data store from this block volume. So I would again go to storage, click on add storage, choose VMFS as the data store type. We see the same storage over there, give it a name. Now, let me explain you this screen. So what has happened is that we have replicated a VMware data store, which already had a VMware file system on it. Now, we replicated that data store, which already has the virtual machines and the file system. Now, ESXi sees that volume and it gets to know that you already have the file system that I work with. So what would you like to do? Would you like to change the signature? Because when we create a data store, it has by default some UUID, some internal signatures. So ESXi is now seeing an existing file system that it knows about. So it is asking that, do you want to keep the same signatures or you want to change them? So we can go with both the options. So we can keep the existing ones, or we can choose the first option of creating a new signature. We do not want to use the last one because that will wipe out the data. So what I would do over here is I would go ahead and choose a new signature over here, and I want to show you that how it looks like. So I'll choose a new signature and I'll hit finish over here. Now, what it will do is that VMware will think about it that it is a data store snapshot. So it will rename the data store, stating with a snap, because it is thinking it is a snapshot of a storage. I see both my virtual machines over here, and basically I see that the entire 100 GB I can see. Now, what I can do is that the virtual machines that I have, I can register these virtual machines on the ESXi, and then I would be able to power them on. So I choose my ESXi where I would like the virtual machines to get registered. I hit finish, my virtual machine registration process completes. In the backend, I go to ESXi1, choose the virtual machine. If you have too many virtual machines, we can quickly look it up. I see my virtual machine and then I'll power it on. Now, when I power it on, it will not complete the process because we were trying to power on a virtual machine from a block volume, from a data store where it already had a VMFS file system on it. So basically what would happen is it is basically asking for a question. So when we hit a refresh button, it is basically asking for a question that what did you do with this virtual machine because you had it earlier? So did you move it or did you copy it over? Now it depends on which option would you like to go ahead with. If you do, I copied it, what would happen is UUID internally gets changed. If you do, I moved it, internal UUID, would not get changed. Now it depends on the requirement that would you like to change the UUID or not. Basically, if you have a very coupled integration with UUID, then you would like to keep it the same. Else you can also change it, no concerns over there. So I'll choose the option I moved it, I answer the question, and this will power on the machine. Now, when I go to the web console, I would see Windows loading up. Okay. So we spoke about block volume, what the options are, and how we can add a block volume, and then how we can format it to create a data store, and then replicate it. Now let's move on and understand the other option that we have is the file storage. Let me share my screen and let's talk about the file storage functionality and how it can help us. Okay, so when I talk about file storage, it can also be used as a secondary storage on ESXi. Here are few use cases that why we would be using file storage as a data store on OCVS. It is available on the service and it's always there for us. Oracle is maintaining it for us. We can have the sizes in exabyte. So with block volume, we have a limited capacity of 32 terabytes. However, if you want to scale huge, and I mean really huge, then we have file storage, which can help us. It gives us a lot of storage, but that doesn't mean that we are paying upfront for that storage. We only pay for what we are using. It works with NFS 3, and it can be connected to multiple ESXis over IP. Now, let me show you a demo on how file storage can be connected to ESXi data store. So let me share my screen again. Please allow me a moment while I bring up that demo for you. Okay, so I have OCVS-SDDC, and it is accessible from the hybrid console. So when I come to my SDDC, I see that, it is provisioned in active in availability domain 1. And now when I scroll down, I see that my SDDC has 3 ESXIs, and it also has a provisioning subnet. Provisioning subnet is the one where my ESXIs are residing. It is basically the management IP where my ESXIs are residing. So what I would be doing is when I am creating the file storage as a service, I would be using this subnet so that it has an easier integration when it comes with OCVS ESXIs. I can have a dedicated subnet as well. However, there I would have to allow rules, establish the connectivity, make sure that the required ports are allowed. By placing it in the provisioning subnet where the ESXIs are there, I would not have to, go through the hustle of allowing the connectivity rules because it resides in the same subnet. So this is the subnet that I have, the provisioning subnet, which I would be using further. So now this is my vCN that I have, which I have created. And this is my subnet that I was referring to earlier, where my ESXIs are deployed by default. Now, when I go to the file storage system, I click on file system. And over here, I'll give it a, an easy human readable name. So I'll just give over here as OCVS. I'll choose again AD1 over there, give an export path file name. This can be anything that you feel like. If you would like to change it, definitely we can change it. And now in the mount target, we would have to specify that what name we would like to keep. We have a by default name, but we can again change it and choose the vCN and the subnet where we would like it to be connected to. So we are choosing the ESXi subnet because we would not have to allow then the rules and the ports, for the communication to go okay. Within the subnet, the communication would work well. So it will take a couple of minutes for the provisioning to get completed. Once the provisioning is completed, we would see it in the active state. And then we would see that our export path is in the creating state. It will take a couple of minutes and then it will change to active state. Now, once it has changed to the active state, what I need to do is that I need to, again, get the details so that my ESXi gets to know about it. And the way I would do it is that I would basically go to the export path and then click on the mount command option. And here are the details, that I need to use for my ESXi. So I'll go to my cluster and I'll make a right click on it and go for the option storage. Click on new data store. And here I would now be creating an NFS file system, NFS data store. I'll be choosing NFS3 and then give it a name. It can be any friendly name that you would like to keep. Again, you specify the name for easier understanding. Now for the folder name, I'll go back to the Oracle portal. And this is my export name or the folder name that I need to copy and paste it over there. And same would be applicable for the IP address as well. I'll copy that IP address over there from the Oracle portal and mention it on my portal. Hit next. And I would like to connect it to all my ESXIs. And I choose all of them and hit finish. And it'll take a minute and it'll get connected to all my ESXIs. Now, when I go to my ESXIs, I see 2 data stores, NFS3, and I see my local vSAN data store.